Hello again and welcome to another flipped classroom where today we are going to be looking at completing the square. Now we had a brief look at this last year, however we need to come back and we've separated it into another exercise because, well, let's face it, you've had enough trouble with factorizing in exercise 4B already. Alright, getting straight into it. Before we look at the actual method, we need to remember a few important expansions. Now, this one over on the right we've already used with our factorizing. So if you have an a minus b and they are all squared, it comes out into a squared minus 2ab plus b squared, and a plus b squared comes out to be a squared plus 2ab plus b squared. So if we want to factorize and we've got two terms which are added together and they are all squared, or we have two terms that are subtracted, all squared, these are the expansions that they come out to be. Now it's important to remember exactly what these look like because they will help us when we use our completing the square method a little bit later on. Now to make these a little bit more familiar, if you have a look at your page a little bit further down, if we substitute x in place of a, where it would usually be in the brackets in both of these cases, when we expand them out, these expansions look a little bit familiar because we have our x squared term, we have our x term, and then the b's just represent the constant terms or the coefficients in each of these cases. And same here with our, when we substitute the x in, we get our x squared term. We have 2b, which is just a coefficient of x, and then b squared is our constant term at the end. Now, once we put in that x, like I said, these results look a lot more like quadratics. So we need to remember these expansions. These are very important that you get in your head that x plus b squared is equal to this, and x minus b squared is equal to this expansion here. This is highly important because it is, well, to be honest, when we do our completing the square method, like when we did the perfect square method for factorization, to be able to recall what a quadratic looks like as soon as you can see it and what factorization method you are going to use to solve this question is going to save you so much time in the test. Okay, here's the method. A lot of text. Now, when solving quadratic equations, we need to, first of all, we already know that the right-hand side must equal 0, so moving everything over until the left-hand side. Once you have that, then we can move on to these following steps, and I'll just label them 1, 2, 3, 4, 5, and 6. So, first of all, when you find a quadratic that cannot be factorized normally, and if you remember back to the examples we did, there was one which I said you couldn't factorize normally, but under a different method we could. This is the said method. So if you find you cannot factorize it using the cross method or any other methods we've discussed so far, these are the steps you need to follow. First of all, we move the constant term to the right-hand side. The constant term is simply just the number which doesn't have an x attached to it, so the number that comes at the end. We move that to the right-hand side. Then we halve the value of the coefficient of the x term and square the result. That's a lot of stuff to do. We'll go across that step by step in the examples. Next, we add this number to both sides of the equation, factorize the left-hand side as a perfect square, and then we solve it from there. Alright, so these are the steps. We're going to go over them one by one in each of these examples to make sure you understand how to do each. Alright, so first example, x squared plus 6x plus 2. Now, if you got this in the test, you know that you would start looking for factors of plus 2, and you'd see, well, factors are 1 and 2, that's it, and none of them add together to give you 6. So hypothetically, in the test, if it didn't say to solve using completing the square method, you could know immediately that this can't be factorized using the simple solving of a quadratic equation, so we have to go back to completing the square. Okay, now let's have a look at our steps and go through them one by one to help us solve the equation. So, first step, move the constant term to the right-hand side. Right. Okay, so we've got plus 2. So if we want to move it to the other side, we need to subtract it from both sides. So now our equation is going to become x squared plus 6x equals minus 2. Alright, what's the next step? Halve the value of the coefficient of the x term and then square the result. Right, so the x term, this is the x squared term, this is the x term, the one that's just sitting by itself. So we need to halve that number and square the result. So if we were going to take that, let's do a little bit of working up here. The x term is 6, and we had to halve the result, so divide by 2, and then square the result. Okay, so 6 divided by 2 is 3, and then 3 squared is 9. Okay, so what were we going to do with that number? So step number 3, add this number to both sides of the equation. Remember, add is the important word here. Okay, so we're going to add it to both sides. Now remember, if we do something to both sides of the equal sign, we're not changing the question as long as we do it to both sides. Okay, so that takes us to x squared plus 6x plus, oops, I wrote a 9. I said 6 and then wrote a 9. Alright. 6x plus 9 equals minus 2 plus 9. Okay, now what do we do? Step 4, factorize the left-hand side as a perfect square and simplify the right-hand side. Okay, so having a look at the left-hand side, we've got x squared plus 6x plus 9. Now remember I said we had to remember those simple expansions from before. Let's go back and have a look at them. So if we have something that's x squared plus 2 times some number and then plus that same number squared, well, that comes out to be x plus that number all squared. So getting back to our question, well, we know that this is just 3 squared, and this happens to be 2 times 3. So that must mean that the b, or the number that we're referring to in that expansion, must be the number 3. So if we were to factorize this left-hand side, it would come to be x plus 3 all squared. And if we were to simplify the right-hand side, minus 2 plus 9 is 7. Makes sense? So the expansion, if we were to write it here, x plus b all squared equals x squared plus 2 times whatever that number b is, x plus b squared, so that number squared. So looking at what we have here, the number at the end is 3 squared, and 2 times 3 is also 6, so it fits this form here, meaning that we can immediately factorize it to this guy here. See how knowing these expansions can help you immediately factorize it from here to here. Okay, let's have a look at our next step. We've simplified and factorized. Take the square root of both sides of the equation, remembering the plus or minus on the right-hand side. Alright, so this is the part where we start to solve our quadratic equation. So we're going to take the square root of this side and the square root of this side. So we get x plus 3, because the square root removes the squared, and that equals the square root of 7, or plus or minus the square root of 7. Remember that game that we played in class where I said I was thinking a number, and when I multiply it by itself, it equals 4. And you can have two answers because you can have positive 2 and also negative 2. And the same thing goes for this question. If we have a look at our brackets in here, we are squaring some number inside here, and it's going to equal the square, well, it was going to equal 7. Now that number could either be a positive number or a negative number and still give us the answer of 7. That's why when we remove the square, we have to give a plus or minus to the other side. Right, so that means x, if we subtract 3 from both sides, x equals plus or minus the square root of 7 take away 3. Now you can take that a step further if you want. You could say that x equals the square root of 7 minus 3 and put it in your calculator to get your decimal, and then do the negative version of it. Do minus the square root of 7 and take away 3 and get, see what you get as well. Both answers are correct, but I think for the test we'll probably get you to write out both of them. So do plus root 7 minus 3 in your calculator, and then do minus root 7 minus 3 in your calculator and give us both of those answers. Okay, so there are the 5 steps. Let's go through them again with the next example to make sure that we're up to scratch with following and completing the square. Okay, example number 2. X squared minus 3 equals 5x. Okay, so the first thing we need to do is turn this into a quadratic equation, which means that the right-hand side must always equal 0 and not 5x. So we're going to move this over to the left-hand side. So that's going to give us x squared minus 5x minus 3 equals 0. Right, now we can start solving it using those steps. Going back, step number 1, move the constant term to the right hand side. Okay, let's plus 3 plus 3. So x squared minus 5x equals 3. Then what did we have to do? Halve the value of the coefficient of the x term and square the result. Right, so halve the value of the x term, so this guy here, halve the value of this guy and square it. All right, let's do that over here. So in brackets, we're going to take out minus 5 and halve it, and then square the result. And what are we going to get? Time to grab our calculators out. And minus 5 divided by 2, and then squaring the result. And the answer is 6.25, which we can write as 6 1/4, or we can write that as 25/4. Okay, so once we have got that value, what's our next step? We had to add it to both sides. So we're going to add it to 25/4 here, and add 25/4 here. So our question now becomes x squared minus, almost did a plus, minus 5x plus 25/4, and that equals 3 plus 25/4. Alright, now we had to factorize. Now to help you do this, because we've got this big fraction here, I'm going to let you in on a secret. Notice in the previous example here how once we had got our final equation, we had a look at it, and we noticed that first of all it had 2 plus signs, which linked up with the 2 plus signs that we had in this expansion here. And the number that we used inside the brackets here, the plus 3, was the same number that we used inside the brackets here. 6 divided by 2 was 3, and then we squared it to get our number that we added to both sides. Well, if we look back at our expansions, we've got two. We've got two plus signs give us this expansion. A minus and a plus sign gives us this expansion over here. So that means, looking at our question, that first of all, in our equation, we've got a minus and a plus sign, which means that our expansion is going to be x minus b squared. And second of all, if we have a look inside the brackets here, that's just the number that's going to be, that's our b. So that means our factorization is going to be x minus 5 over 2 squared. Make these brackets a bit bigger. And that's going to equal 3 plus 25 over 4, which equals either 9.25 or 9.25 or 37 over 4. Okay, and now we solve it like we did in example 1. So we take the square root of both sides, and that removes the squared. So our next line is x minus 5 over 2 equals plus or minus the square root of 9.25. And then we add 5.2 to both sides to give us x equals plus or minus the square root of 9.25 plus 5 over 2. So you've still got two answers. You've got 9.25 plus 5 over 2 and minus the square root of 9.25 plus 5 over 2. And that's your two answers again. All right, next one. 3x squared plus 12x minus 3 equals 0. Okay, now this could be a trick question because look at this quadratic. Remember when we did our questions in exercise 4b, one of the first things that you were asked to do before you tried to solve any question was to take out a common factor and look at each of these terms. We've got a 3, a 12, and a minus 3. That has a common factor of 3 inside. So if we were to take that out, we would get 3 bracket x squared plus 12, not 12x, plus 4x minus 1 equals 0. Now, what we can do is we are going to take the 3 away from this side now so that we can focus on the quadratic that's inside the brackets. So I'm going to move it from the left-hand side to the right-hand side. Now remember, when we're dealing with equations, if I want to move something from one side to the other, I must do the complete opposite of what's currently written. So this is 3 times what's inside the brackets. So I'm going to need to divide both sides by 3 to remove it, and that leaves me with x squared plus 4x minus 1 equals 0 divided by 3 is still just 0. Right, so now I can deal with my quadratic and I can complete the square. So first step was, remember, to move the constant term to the right hand side, so plus 1 to both sides. That leaves me with x squared plus 4x equals 1. Right, now I have to look at my x term, and we'll do our working out over here again. So I had to halve it, so 4 over 2, and then square it, and that gives me 4 divided by 2 is 2 squared. Oh, well, that just gives me 4. And I take this term and I need to add it to both sides. So plus 4 plus 4. That gives me an equation of x squared plus 4x plus 4 equals 5. Now I need to solve the left-hand side. Now which expansion is it? Is it going to be the x plus b squared, or is it going to be the x minus b squared? Well, if you remember, it's going to be the x plus b squared, which is x squared plus 2bx plus b squared. And where do we get that b from? Our working out that we did over here, whatever is inside the brackets is going to be our b. So when we factorize, it's going to be x plus, well, 4 over 2 is just 2 squared, and that equals 5. Now we solve. Take the square root of both sides. So that gives us x plus 2 equals plus or minus the square root of 5. Then subtract 2 from both sides. X equals plus or minus the square root of 5. Take 2. So we've still got two answers. We've got the square root of 5, take 2, and minus the square root of 5, take 2. Alright, so this is how to solve quadratic equations using completing the square. Here are some practice questions for you to work on, and we will give you the answers to these two practice questions when you get back into school tomorrow. Alright, I hope you've enjoyed this lesson. My name is Mr. Rappell, and I will see you guys in class tomorrow. Bye.